Good morning class, welcome to ST.PETERS school. This is a science class, and in previous class we were doing the chapter current and electricity, and we have done the topic free electrons. And what is free electrons I will explain. So what is free electrons? Free electrons like in every substance, but in the conductor substance like a metal, iron rod, or the steel, through which the current can easily pass, they bears some free electrons. Due to help of these free electrons only, it is possible to transfer the charge from one end to another end. Now the question is okay, so the one point is written in your book that, okay, so first read the paragraph of the free electron. Every atom of a metallic conductor has one or more outermost electron which are very weakly bound to the nucleus. These are called free electrons. What is free electrons? It's a कोई भी मेटालिक कंडक्टर होता है जो उसके आउटर मोस्ट लेयर पे होते हैं, सम फ्री इलेक्ट्रॉन्स आर मूविंग विच आर वेरी वीकली बाउंड टू द न्यूक्लियस, एंड दीज आर कॉल्ड द फ्री इलेक्ट्रॉन. Okay, so these electrons can easily move from one part of a conductor to its other part, and the negative charge of the electron also gets transferred as a result of this motion. The free electrons in a conductor are the carriers of negative charge. Okay, remember electron is having a negative charge on it. हर electron के ऊपर negative charge होता है. So you have to remember this. Okay. Now the question arises in your mind that if the electron is moving in the every conductor, now then why don't we feel electricity in any metal? So why don't we feel current in the like the rod which is like this? Because the electrons are not properly moving in one direction. When electron will move in a particular direction, then only the charge will flow, then only we will feel the current. But in this case, what you are saying, that one electron is moving this side, one electron is moving this side, one electron is moving this side, one electron is moving this side. So what as a result what happened? The charge is not flowing in a proper डायरेक्शन. हर चार्ज एक दूसरे को कैंसिल कर रहा है. दैट्स व्हाई वी डोंट फील करंट इन एनी मेटल रॉड व्हेन इट इज नॉट कनेक्टेड टू द any wire. Okay, now to move the charge, to pass the charge, it is very important to align the electrons in a one line. अगर वन लाइन में वो अलाइन होगा तभी इलेक्ट्रिसिटी वन एंड से सेकेंड एंड पे वो पास करेगी, एंड देन ओनली करंट कैन पास. Now to align, what we have to do, we will connect this metal rod to the wire. Okay, we will add one battery here having positive and negative charges. Okay, we all know that positive and all the electric cell has two end, that is positive, and one is negative charge. Okay, so now what will happen when we are studying the high potential and lower potential? In that case, we have seen that current used to flow from higher potential to lower potential. Yes, so plus charge is known as a higher potential and negative is known as the lower potential. Okay, so current will flow from here and it will flow like this. Okay, but when you will see the picture, you will see that electron is flowing in this direction, and I am telling you that the current will flow from this direction to this direction. So actually what happened, why this happened? Because all the electron is having negative charge. So when all the electron is having negative charge, if the electron will come this side, what happened? It will repel. Negative charge will repel each other. We all know that negative positive attract each other, while negative and negative repel each other, positive repel each other. Okay, so this is the reason what happened. Electron always move in opposite direction to the current. If the current will move in this, if the charge will move in this direction, electron will move in the opposite direction. So remember, this is very important term. Okay, so in the same thing has been explained here. Current flowing through a wire, as shown in figure 3.4. If a conducting wire is not connected to a cell, its free electron move randomly in all directions in the space between the atoms. When we connect the ends of the wire to the two terminals of cell, electric force acts on the electron. Being negatively charged, they start moving from the negative to positive. Okay, higher potential to lower potential, as shown in figure 3.4b. Due to the flow of these electrons, current starts to flow through the wire. This motion of electron is irregular, but there is a definite non-zero value to their average velocity. Okay, so in that case, what happened? Average velocity of the moving electron is 0, or they are aligned in a same direction. Now what is electric current? Okay, so an electric current is a flow of electron through a conductor. Quantitatively, current I is defined as the charge passing through the conductor in unit time. Okay, so what is I? I is a current. It's not a current. What is current? Current is a movement of charge. Charge को हम denote करते हैं term Q से. I is a current. So what is current? Current is a definite charge passes through a particular area. That is the particular current flow from the particular section. For example, suppose there is a rod and I am telling you to just find out the area of this portion only. So how you will find the current for this reason? You will first of all find out how many charges are moving from this area and what is the particular area. So I is equal to Q by T. The unit of a charge is SI unit is coulomb. I को हम coulomb से ही denote करते हैं and current is चार्ज को हम कूलम से डिनोट करते हैं, करंट को हम एम्पेयर से डिनोट करते हैं. द चार्ज ऑफ वन इलेक्ट्रॉन इज 1.6 इंटू 10 टू द पावर -19 कूलम. रिमेंबर दिस इज वेरी इंपॉर्टेंट. यू हैव टू रिमेंबर दिस टर्म दैट वन इलेक्ट्रॉन कैरीज द चार्ज ऑफ 1.6 इंटू 10 टू द पावर -19 कूलम. Now what is ampere? Ampere is a unit of current. 1 ampere current is said to the flow in a conductor if 1 coulomb charge flows through its every second. So अगर हम देखें कि I is equal to Q by T, तो Q पर इलेक्ट्रॉन का जो चार्ज होता है 1 coulomb is equal to 1.6 into 10 to the power -19 C by 1 second. Okay. So do you know it's in a pink color block you will see some fact has been written here. Very small value of current are expressed in the following. 1 milliampere in last class also I explained it to you. 1 milliampere and 1 microampere. Okay, 10 to the power milliampere's value is 10 to the power -3 ampere and microampere means 10 to the power -6. So sometimes you can write at the place of 10 to the power -6 you can write 10 directly 1 microampere or you just give the unit of microampere और जहाँ पे भी आपका वैल्यू 10 to the power 3 आता है एम्पेयर, then in that case you will write down 1 milliampere in place of 10 to the power -3a. Okay, now you will see example has been given here. A current of the 0.4 ampere flows through a conductor for 5 minutes. How much charge would have passed through the conductor? So it's totally based on the formula we have just seen कि current इस केस में current दिया हुआ है, the value of current has been given, the time which is taking to pass the current, then it's asking about the value of charges. So how you will find I is equal to Q by T. Okay, or Q is equal to I into T. So you will just put the formula and you will get the answer. Now what is resistance and Ohm's law? Okay, so first of all, what is Ohm's law? The relationship between the current flowing through a wire and the potential difference across its end can be obtained from the law that was given by the German scientist George Simon Ohm. The scientist's name was George Simon Ohm. He was a great physician. He was a great physical scientist. Okay, so if the physical state of a conductor remains constant, the current flowing through it is directly proportional to the potential difference between two ends. ओके, उन्होंने ये बोला कि आई जो है करंट जो है वो डायरेक्टली प्रोपोर्शनल है वी के पोटेंशियल डिफरेंस के. ना व्हाट इज पोटेंशियल डिफरेंस? जो हायर पोटेंशियल लो पोटेंशियल का जो डिफरेंस होता है दैट इज कॉल्ड पोटेंशियल डिफरेंस. सो वो करंट जो है वो टोटली डिपेंड करता है उसके पोटेंशियल डिफरेंस से. नाउ टू मूव दिस वी ऑल नो दैट जब भी हमें ये डायरेक्टली प्रोपोर्शनल का जो कॉन्सेप्ट मिलता है वी हैव टू रिमूव दिस. Okay, so here what he has done, he has removed this directly proportional term with the help of k. K is a constant here. Okay, it's a type of जो you can say kinetic energy or you can find out. So I is equal to 1 by k is equal to v. Okay, why it has been written? K को इधर हम लाए हैं like in the left side and what we got I into 1 by k. K is in a multiple, so it comes here in the division and I into 1 by k is equal to v, where 1 by k is equal to r. R को हमें यहाँ पे constant माने. What is r? R is nothing, it's a resistance of conductor. Later on we will see what is r. but for now you just understand R is the resistance of a conductor. So I into R is equal to V. You also remember R is equal to 1 by K. Okay, K is nothing, it's a K is a constant of proportionality. K को it's not kinetic energy, it's a constant of proportionality. कभी भी हम direct proportional को अगर हमें remove करना हो तो हम we just put the K. K is a constant of proportionality. Now we took the formula of 1 by K is equal to R. 1 by K को हम यहाँ पे R मान रहे हैं. R is what? R is the resistance of conductor. So I into R is equal to V, or hence V is equal to IR. Or you can also derive another formula, R is equal to V by I, and this is only known as the Ohm's law. In blue box you can see physical state of a conductor means its length, area of a cross section, temperature and material it is made up of. ये सब constant रहना चाहिए in a the current flowing two different flowing current rod. Okay, we can obtain SI unit of resistance from above formula, potential difference. So abhi now we can find out the unit for R, V and the current. And so we can potential difference and the current are measured in volts. Potential difference को हम volts से show करते हैं. Current are measured in ampere respectively. So the unit of resistance will be ohm meter. Okay, it is indicated by symbol ohm. ओम से उसको डिनोट किया गया रेजिस्टेंस को. सो 1 ओम इज इक्वल टू 1 वोल्ट बाय 1 एम्पेयर. वोल्ट यूनिट ऑफ वोल्ट इज वोल्ट एंड एम्पेयर. सो वोल्ट बाय एम्पेयर इज इक्वल टू 1 ओम. Okay, so resistance of 1 ohm if 1 ampere of current. Okay, so now you have to define the formula, and as per we derive the formula, you can also say that resistance of 1 ohm if 1 ampere of current flows through a conductor when 1 volt potential difference is applied between its end, then the resistance of the conductor is 1 ohm. Okay. Now resistance and resistivity of the conductor. Now we will see what is resistance and what is the resistivity of a conductor. So as shown in picture 3.4. So where is the picture 3.4? Let us find out first of all. Okay, I think it's above only. 3.4. Look at the picture. Okay, when we are looking up to the motion of electron, we can see, just look the picture very carefully and then look into your book at the image 3.4. What is written here? Okay, so in as shown in figure 3.4, there are a large number of free electrons. There are a large number of free electrons in a conductor. They are constantly in random motion. When a potential difference is applied between the two ends of the conductor, these electrons start moving from the end at a lower potential to the end at a higher potential. This directional motion of the electron causes the flow of current. Moving electrons strike the atoms and ions which lie along their path. Such collision causes hindrance to the flow of electron and oppose the current, and this hindrance is called the resistance of conductor. So what the obstruction comes in the path of moving of the electron, like electron moves in opposite direction, then how the charges passes. So charges passes, so there are some few positive charges are also present. So positive charge move and hence they help the current to pass through it. Now what is resistance? When a potential difference is applied between the two ends, जब potential difference apply किया जाता है, then at the end of the two conductor, these electrons start moving from end at the lower potential to end of the higher potential. वो lower potential से higher potential move करता है electron. This direction movement of electrons cause the flow of current. Moving electrons strike the atoms and the ions which lie along their path. और जो बाकी जो with the electrons जो nucleus के very close रहते, that possesses the obstruction in their path, and that is only called the resistance. Okay, what is resistivity at a given आप यू कैन अंडरस्टूड लाइक कि करंट के फ्लो में कोई भी अगर जो भी एटम्स उसको डिस्टर्ब करता है, दैट इज कॉल्ड रेजिस्टेंस. ओके, एट अ गिवन टेम्परेचर द रेजिस्टेंस आर ऑफ अ कंडक्टर डिपेंड्स ऑन इट्स लेंथ, एरिया ऑफ क्रॉस सेक्शन एंड द मटेरियल इट इज मेड ऑफ. Okay, so if the resistance of a conductor is R, then R is directly proportional to length. It has been derived by the scientist that R is directly proportional to length. अगर length increase होगा resistance increase होगा, length decrease होगा resistance decrease होगा. So R is also directly proportional to 1 by area. If the area will increase, resistance will decrease. If the area will decrease, रेजिस्टेंस विल इंक्रीज. वाई दिस हैपन्स? बिकॉज हमने क्या समझा कि व्हाट इज रेजिस्टेंस. जो इलेक्ट्रॉन, जो फ्री इलेक्ट्रॉन्स मूव करती है फ्रॉम लोअर टू हाई पोटेंशियल, देन इन द पाथ ऑफ अगर एरिया बढ़ जाएगा तो दे कैन इजिली मूव, राइट. तो अगर इफ द एरिया विल इंक्रीज, रेजिस्टेंस विल डिक्रीज, बट इफ द लेंथ विल इंक्रीज ओनली एंड देन जितनी दूर वो ट्रैवल करेगा उतना वो रेजिस्टेंस उसको लाइक दे हैव टू सफर. सो this is the reason R is directly proportional to length and R is directly proportional to 1 by area. So you can also say R is directly proportional to length by area commonly अगर हम इसको लिया जाए, and it is denoted by this sign you can see here, that is okay. So how will you prove that unit of resistivity is ohm meter? We have already seen this. Different materials are having different resistivity. It has been given here कि copper, nichrome and diamond. Resistivity means like उनके अंदर में इतने ऑब्स्ट्रक्शन होते हैं, निक्रोम में थोड़े कम होते हैं, डायमंड में उससे भी ज्यादा होते हैं, मतलब कम होते हैं. सो दे आर गुड कंडक्टर. Okay, so this is P is the constant proportional and is called the resistivity of the material. The unit of resistivity in SI unit is ohm meter. Resistivity is a specific property of material and different materials have different resistivity. Okay. This is rho. This is called rho. This symbol is called rho. So rho is the constant proportionality and is called the resistivity of the material. The unit of resistivity in SI unit is ohm meter. Resistivity in a specific property of a material, different material have different resistivity. So remember that every material has a different resistivity. The good conductor is having less resistivity, while semiconductor or the bad conductor is having like more resistivity, and copper is having like the semiconductor is having more resistivity. Okay, electric circuit. Okay, in next class we will continue with the next topic. So for today we are going to end here only. In next class we will start with a new topic, that is electric circuit. So till the time what you are going to do, just go through the chapter, go through every point. That is very important. This is very important, one of the important chapter. Different types of numericals you are going to have, you have to solve to the related topics we just now discussed. So go through the chapter. Till the time, take care and bye bye.